Hi everyone. This is Brian from Kala. Happy to join this remotely from New Zealand. So today I'm going to talk a bit about the Jam, the Polkadot 2.0 roadmap. But before everything else, I would just like to emphasize that this is very, very, very new to the point that we don't have any public draft of Jam spec available. There's a thing called CodeGen, but it's a super early version that is like nowhere close to the real one. So I do have access to some like draft of the Jam spec, which is like 58 page long. So I haven't finished reading it. So all these details might not, everything I say might not be accurate. And also, this is again it's new. Everything is subject to change. There are still a lot of unanswered questions. Things might change. We definitely still need to do a lot of proof of concept experiments, etc., to identify if it's actually possible to do this in such way. So a lot of things might change, but at least from high point level view, the high level architecture should be relatively settled. So this will be the things that I would like to focus rather than the low level implementation details. So I'm showing the screen with this Polkadot 2.0 roadmap. This is not the official roadmap from Party, but it's just, so this is like all the resource collected, not by myself. So it's credited to OpenGov.org. So about the Polkadot 2.0 roadmap, including some bunch of high-level descriptions of what is going to happen in the future to about the launching process of this brand new Polkadot. So I guess I can start with something relatively stable, and it's most certainly that will be happen soon-ish. It's the Azure Cotam. So this is going to be live on Kusama in, I don't know, a month or two, and then maybe a few more months to Polkadot. So this is the first step to the Polkadot 2.0. Gabe talked about this on last year Decoded. He already mentioned, highlights a lot of advantages of the Azure Cotam compared to the current PowerChain slot lease model. That will allow significantly improvements the utilization of the block cores offered by the Polkadot. And so I guess I don't need to emphasize too much on those because those are like relatively well known. But basically, in short words, so people will be able to purchase and trade the Cotams and then to launch a new network. This can significantly reduce the cost to launch a new chains secured by Polkadot. And that can definitely allow many new projects that can start trying launching the chains without any upfront capital cost. So that also includes a lot of performance improvements, such as XM backing that can 4 to 8 times boost the throughput of the PowerChain. And then there are also a lot of interesting mechanisms that will be implemented in future, that including multi-core PowerChains, so that a PowerChain can leverage multiple cores for the validations. So that is basically like somewhat similar to multi-thread or multi-core programming, but it's actually kind of different. The PowerChain nodes is still executing all the logic sequentially, but it's all the Polkadot validating the logic in parallel. So that way we can have 2 or 3 times or even more higher the throughput without getting into the complicated details of concurrent programming, which causes a lot of troubles and it's just really hard. But with this Azure Cotam, we are able to taking advantage of the multi-core CPU that we have every day on every machine, but at the same time not getting into the overhead of the concurrent programming model. So if you are interested about Azure Cotam, the party have a lot more resource. Again, also read their RFCs available describing the details. Then the next thing will be the star of the show, the gem. So after the agile quota is implemented, then I can't really give any time that no one knows the timeline. But hopefully we will see a gem chain that being launched with some very, very different powerful abstractions offered for the developers. So it will be essentially a hard fork for Polkadot in some way. So Gen chain will be a new chain, and then we will migrate from the current Polkadot to the new Gen chain somehow. Obviously, we don't have any ideas about exact migration process. That's yet to be finalized. But from the power chain point of view, it should be very straightforward. We just upgrade to, say, the latest version of Polkadot SDK. And on the migrations, we'll just probably see the block finalization stop for a few minutes and everything continues. So from the power chain point of view, the migration is very seamless process. So to the users and the dev developers, power chain developers, the migration process is very straightforward. It's only for example, the Polkadot validators, the user of the Polkadot itself, they might need to be aware of the migration. They have to switching from the old existing Polkadot chain to the new gem chain. But what exactly is the gem and what can the gem offers? So gem, when Gev and the party team building the Polkadot 1.0, they have built a lot of very powerful primitives. And then the whole Polkadot 1.0 is designed around the concept of power chain. So everything are designed to offer the functionality of power chain. Like the rechain is designed to secure a power chain. All the staking logic, consensus logics, validation logics, data availability logics, they are designed to secure power chain. But people have been discovered that now with the current Polkadot, we have built a lot of very powerful components. For example, the data availabilities. We can, in a fairly secure and efficient way, to make a piece of data available. Right now, it's used to secure the power chain block data. But there's no reason that we cannot use this for something else. But because the Polkadot 1.0 is designed in such a way that it's only about power chains, so it's kind of hitting the limits. Right now, we can use it to deliver power chain and on-demand power chains with Azure Cortana, the more interesting stuff. But again, everything is still, a power chain. This basically limit. This is pretty good because we have on all the other blockchains, they are just blockchains. With Polkadot, we can basically have build blockchains. But this is not really enough. So what Gavin is trying to do is create this kind of new abstractions that allow us to build truly decentralized applications that is not just about blockchains. So essentially, it can be used to run any program. Obviously, the program needs to be able to compile and design in such a way to be compatible. But it's truly Polkadot 2.0 is truly the world computer 2.0. With one improvement is this multi-core rather than a single core that Ethereum is currently. So what exactly does this mean to the developers and users? So right now, every blockchain applications, they are designed based on the blockchain models. So if you, for example, user have to send a transaction, after a transaction, there will be a new block. In the new block, there will be a bunch of transaction and storage modification events, etc. So those are how every current blockchain applications are being built, or maybe I shouldn't say blockchain application. Every decentralized applications are being built. They are blockchain applications, basically. That is fine, but it has limits. And with Gem, we can allow truly decentralized application without blockchain. So in some way, we can have a chainless smart contracts, for example. So there is like Atom model is one example. The core play is something a new paradigm that are being developed and proof of concept is being working on by a party. So that allows we deploy essentially a smart contract. It's not exactly a smart contract, but essentially a program that will be invoked upon certain actions. Like for example, you might want to execute a program when your account have received some funds. Then you may want to swap to something else or do some arbitrage or do whatever. And then you can basically deploy your own program and set up necessary connections and ensure your program have enough funds for paying for the service fees when it needs to be run. So that basically solves this. And it's more importantly, it's transitionless, so the input does not necessarily be a transition. Because transition is, like right now transition, we're talking about transition, it's usually a signed transition. Like someone need to sign the signatures and compile, and then the sender can need to have some money to pay for the fees. And there are also unsigned transitions, they are feeders. But there are still like external events to the blockchain. And then with the transitionless program, then we can, the program itself can generate events that run things and do whatever it wants to do. So this enables a lot of new possibilities that was not possible before. But exactly what does this mean to the user's point of view? Well, I cannot really give you a very good answer right now. This is very new, so we kind of need to think about, do a lot of brainstorming, approve some gaps, probably need to do a lot of hackathons, for example, to finally identify how powerful exactly the features they are able to offer by this new models of the decentralized applications. So this is like, I would like to describe it in this way, like with the Ethereum and Bitcoins and most of the layer ones, they are just like you're running a server in your home. The server is available to people to use. It's mostly like HTTP server. Like the user can send in a request, the server will give you a response. If no one is sending a request, the server, well, does nothing pretty much. With PowerChain, the server itself can do its own things because with PowerChain, we have a scheduler, we have a bunch of, we can do certain things on the beginning or end of a block. So the server can run itself doing useful things without users' input. And with Polkadot and shared security, it's more like a cloud server that the PowerChain team, they can, for example, spend some money to rent a machine from a cloud provider for a year. And the cloud provider takes care of the physical machines, everything. And the developers only need to deploy the server and do the things. But that is great that we don't need to take care of the physical machines. It's the security and many other things are handled by the cloud provider. And then especially the interactions with other servers hosted by same cloud providers, it will be much more easier. So this is the XCMPs and the cross-chain communications between power chains. With Gem, we can implement something more to like serverless applications, similar to AWS Lambda. In that way, the developer only need to write some code. They don't need to write the blockchain, which is like right now, it's not that complicated to build a power chain, but like it's still a non-trivial amount of work. There are a lot of things need to be considered when building a blockchain. But developers, they really just want to building some business logics. With the Gem model, this is possible. They can just building a business logic, deploy it to the Gem server directly, and the Gem can run it. And the another advantage of the serverless model is that there's no physical server. there is still physical server, but it's being abstracted. And so the developer doesn't need to care about where the code is being running on, and also how many machines are required to run this. It can set up to as many as required. So similar thing happens to Gem. The developer can deploy a piece of code. They can be triggered by certain actions, and they can also consume multiple cores at the same time. For example, I might deploy some special design swap applications. A single application can handle maybe 10 transactions per core time block. And then when there are 100 people trying to transact at the same time, I can just purchase 10 cores at the same time and process all these 100 transactions in 6 seconds. So that way we can scale very, very well horizontally. So the latencies won't be limited by the number. So basically we can clear the transaction pools very efficiently and provide much, much better user experience to the users. And Polkadot, in theory, can offers, in the concept way, I think Kusama are going to start with 80 cores or something. In theory, can offers like 200 something cores or more. I don't know exact number. No one knows. But it's definitely a big-ish number. So we can be able to provide a very, very high throughput to the applications, and applications can actually leverage those cores. With the current blockchain models, a blockchain can purchase maybe 2 or 3 cores at a time to validate blockchain nodes, but there's no way a blockchain can leverage, say, 50 cores at the same time. But with the new models, that will be possible. So those are just some examples that I can think of right now that can be done with Gem. What Gem truly offers is that it abstracts the logics of everything. It kind of exposes the underlying components that is currently being used and designed for blockchains, but make them generic enough, allow people to build whatever servers they want to build. So blockchain servers is only one example that can be viewed by Gem. There will be other servers, I don't know. Most likely we might have an EVM servers, allow people to just deploy smart contract EVM codes and run it. There definitely will be a lot more other servers could be implemented. There will be most likely, for example, a data availability server, allow people to upload things and make them available for L2s or even L3s. But yeah, those things are, we still need to build them. So there's a lot of work required. Even for the Gem itself, there are still some dependencies that need to be implemented before Gem is possible. So some of the dependencies have been listed here. So one thing is the XMP and XMQ. So XMP is required to enable the truly peer-to-peer message communications between power chains. Right now, we are using HRMP, so every question message are relayed by the relay chain, which is not that efficient. To be able to fully expanding the number of power chains and cores, we need a truly peer-to-peer communication between the power chain directly. So this is like, there's nothing really difficult, but just need to be done. The Polkadot is going to, in the transitioning to the sky minimum relay or Hermit relay model, that is by moving all the features from Polkadot to a system power chain. So we already have asset hub, we have collective, we are going to have a bridge hub chain, and then there will be a new people chain and the broker chain, and there definitely will be a lot more other chains coming up to start reducing the features of Polkadot. For example, right now we do staking and governance of Polkadot, mainly staking, governance, and transition of Polkadot. We can kind of stop doing transition transfers on Polkadot. Instead, we can do them as a hub with the lowest transition fee. The staking will be eventually moved to a staking chain, and the governance will most likely move to the collective chain. So that way we can allow Polkadot to be kind of featureless. It doesn't have any features other than validating the power chains. So that will also, this is a requirement for the gem, because the gem, there's no relay chain. There's a gem chain that does not have any features that user can use. Every features will be offered by a servers. Well, the only features the gem offers is deploy a new servers. And then, deploying your servers is also a service offered by Gen. So in some way, you don't really integrate with Gen at all. You only integrate with servers offered by Gen. So to transitioning from current relation to the Gen chain, we need to basically move every features to a system power chain. And then the migration of the system power chain from the current relation to the Gen chain will be fairly easy. As I previously mentioned, that will pretty much make the migration seamless to most of the people. Another kind of dependency for Gem is PolkaVM. So Polkadot is a substrate is using Wasm currently, which is a good virtual machine to be a secure and efficient way to run untrusted code. But Wasm is designed for running applications in browser. It's not exactly designed for the blockchain purpose. So there are a lot of difficulties to integrate Wasm with Substrate and Polkadot. Party have spent a lot of time trying to work around those challenges, but it have been kind of figured out it might be best just use something else. And in this case, RISC-V is being suggested to as the new VNs. So RISC-V is a much significantly simple VNs compared to Wasm. It's super efficient, it's well supported. And the most important thing about the RISC-V is that it enables secure metering. One of the biggest hurdle, at least in my opinion, to the PowerGen developers is benchmarking the transitions to measure how much compute time and storage are used by each individual transaction. And so that we can charge the fee accordingly. This is just kind of tedious and work. If not done correctly, it can be a security risk. And then with the metered RISC-V VNs, we don't need to do benchmarking anymore, because executions, the amount of resource required to execute a piece of code of a RISC-V program can be securely measured and controlled, limited. We can set the uppercase limit, and then we can ensure the execution will not consume more resource than the guess limit requires. So this makes a lot of executing untrusted code like smart contracts, for example, much safer, because it cannot use more than resource than the guess limits allows. Another main benefit is enables the state snapshot and capture and restore. So that means you can run a piece of code, stop it at any point, take a snapshot of the heap page, and then later on, for example, on the next block, resume the same program, restore the heap page, resume the program, it will just continue runs. So you can write a program that say takes, 2 minutes to run. Previously, such thing you cannot run such program on the blockchain because every block needs to be finalized, needs to be executed in a few seconds time. You cannot have a 10 minutes block time. There will be a trouble. So, but now with PolkaVM, you can write a program that run a lot of calculations, that takes 10 minutes, and it will be run perfectly fine. It will simply split the executions across many blocks as many blocks as needed. It might just run forever. If you have enough, or run as long as you have enough fees to pay for the executions, the program doesn't need to stop. It will just run as a normal synchronized program run. So that makes a lot of logic significantly simple. You don't need to, like, for example, divide the work into a small pieces and run each individual pieces per block. You can just build your program in the most natural way you need. This also make another. This also solve another problems with async communication. Right now, all the question communication are asynchronized. Basically, when a blockchain want to send a message or send a question transfers, it will send a message, and then after certain amount of block, there might be a response coming back, say, hey, the message is executed successfully or it failed with this particular error. And then you need to handle this on a future block. So this requires a lot of additional work trying to figure out how to handle, like, remember there's a pending message, and then later when the message response received, you might also want to do additional work. And then this kind of back and forth work can be super complicated to implement. And it's very easy to write code that, for example, doesn't handle errors or timeout, or unable to do things incorrectly if the message arrives in unexpected orders. So basically, async applied programming is just hard in general. But with PolkaWorld and the Gem servers model, it will be possible. This is not specified on the first version of Gem, so you're not going to see it on the first day when it launches. But yeah, one day eventually, we can make the question communication be a synchronized communications. So a parachain can, for example, call another functions of another parachain, and then another parachain can return something back and compare to the current parachain to do something in a single block. That will make things like, for example, flash loan, question flash loan possible. So this is implemented by, because as I said, it's possible to stop the execution programs. So when the parachain is trying to invoke to another parachain, we can just stop the current parachain program and start the new parachain program, and then just process the message, return something, and stop the parachain, and then come back to the current parachain and give back the message response. And from the developer point of view, there's just like a normal function calls. There's no need to handle things like if there's come back after 5 blocks or not. It's just a normal function calls. So this just makes concurrent multi-chain interaction super easy, makes everything super composable. This is one of the one of the main difference between composing smart contracts on Ethereum, for example, compared to composing all the functionalities offered by different parachains. On Ethereum, composing smart contract code is just call it and it will return you something, and then you just do logic. It's that simple. That makes a lot of interesting protocols possible. But composing parachains right now is just super complicated. We need to call other parachains. It will come back something after a few blocks. I will need to remember, this is we got this message. We need to continue doing something else, and it's, especially if like multiple parachains are involved. That's one of the reasons why I believe that we don't really have any XCM use cases involved with like multiple parachains, because it's just too complicated. It's not implemented. But with the PolkaWorld, this is we can solve this problem easily. Serverless is the new consensus model. They will be replace the BAPE block authoring logics. It allows focus block authoring and many advanced new properties, but it's not super important. Well, it's important, but to the developer's point of view, it's not really something we need to be studying into details. Yeah, so this also have some additional resources about Gem. Yeah, I think I talked most of the things that I think that will be relevant about Gem. So I guess I will stop here and see if there are any questions.